The most well-known explanation for Euler's number E is about money. The explanation is this. So we're gonna put $1 into a bank. So currently I have $1. And this bank is really generous to give an interest rate of 100%. So by the end of the year, I'll have $2. But now I can just go talk to the bank and say, what about this? You give me 50% interest for the first half of the year, and then another 50% for the second half. $1 becomes $1.50. And then I'm going to use my calculator here. Okay, so now it's 2.25. So we get $2.25 at the end of the year. If we get the interest 2 times, we split it into 2, we get 2.25. If we split it into 3, so we'll have 1. And then we have 4/3. And then we have 16/9. And then after increasing this again, we have 64/27. And this approximately equals 2.37. So that's higher again. If you see a pattern, so what about 4 times? 4 times we have $1. So we're gonna increase it by a quarter 4 times. So it will become 1 plus a quarter to the power of 4. And that approximately equals 2.44. So this pattern goes on. So it increases every time. We can do like any arbitrarily large number. So does it mean that we can just get infinite amount of money? So we start from 1. So $1 becomes $2, and then we have $2.25, $2.37, $2.44. We can do an arbitrary large number. So what if we do it like 20 times? Let's try this. So this is 1 plus 1/20 to the power of 20. So this approximately equals 2.65. Okay, so this pattern just goes on. So does that mean we can have infinite amount of money if we just divide this infinitely many times? Okay, the answer is no. So let's rub everything out. Okay, if we divide the interest n times, we will get the value of 1 plus 1/n to the power of n. So what if n goes towards infinity? So mathematically, this is known as limit of n approaching infinity, and then 1 plus 1/n to the power of n. And this limit equals e, which is 2.71828 ... I don't remember all of it, but sure. Okay, this is a definition of E. But how do we prove this is E? Like I just told you this is the definition of E. But using some other definitions of E, you can actually prove this. So let's rub out this entire thing. So let's try to calculate the limit. Get our hands dirty and calculate it. So limit from n going towards infinity, 1 plus 1/n to the power of n. Okay. So doing this, we're gonna first do let's let y equals 1 plus 1/n to the power of n. And then we can do this. So we can log both sides, use the natural logarithm. Natural logarithm of y equals natural logarithm of 1 plus 1/n to the power of n. and due to the logarithm rule, we're going to do n, it will become n and times natural logarithm of 1 plus 1 over n. So we're gonna do the limit on both sides. So that means a limit from n to infinity, and then the log of y, that equals the limit from n to infinity, n log 1 plus 1 over n. We'll continue it here. So let's calculate this limit. So this is an indeterminate form because n is infinity, and this is actually 0 because 1 over n approaches zeros, and log 1 is 0, so this is 0. So the indeterminate form of 0 times infinity. But we can arrange this like this. So this will equal to the limit of n towards infinity, and then the log of 1 plus 1 over n, and that divided by 1 over n. And you can use the L'Hopital rule on top and bottom, which is, so this equals the limit from n to the infinity. The top, using the L'Hopital rule, will become 1 over 1 plus this, because the derivative of natural logarithm is 1 over x. So this, and times, using the chain rule, times negative 1 over n squared, and that over the bottom is negative 1 over n squared. So look, these cancel out. So this, and then we only have this part left. So this part left, we can just do, so limit n towards infinity. So this just equals 1 over 1 plus 0, because 1 over infinity is going towards 0. So this equals 1. So since this limit is 1, we're gonna do, so that means the log of y equals 1. So that means y equals e. So since this is 1, we found it, so y equals e. So y is the original equation. So this is a proof of 1 plus n, 1 over n to the power of n is e. Thanks for watching, and please leave a like and subscribe.